Hello, welcome back to Morning Glory. It's me, Lexi Matthias. Today I have a special guest here with me, Dr. Elise Nelson, who is telling you a little bit about the muscle contraction. Dr. Elise Nelson, it is our pleasure having you here today.
The pleasure is mine.
So let's get started. How does the muscle contraction work?
As I look at my notes here, the sliding filament theory is a proposed mechanism of muscle contraction in which the actin and myosin filaments of a straightened muscle slide over each other to shorten the length of muscle fibers. There are 3 stages to this contraction. The first one is muscle activation. The motor neuron stimulates an action potential impulse that passes down the neuron to the neuromuscular junction. ACH is released at the synaptic terminal and diffuses across the synaptic cleft and binds to the receptors that trigger the action potential. This impulse is carried through the T-tubule and the action stimulates the cytoplasmic reticulum to release calcium into the muscle cell through the calcium channels. The second stage is the muscle contraction itself. Calcium ions flood into the muscle cell and bind onto troponin. This causes the tropomyosin to be moved to removing activation sites in the actin. The myosin head is at a low energy configuration until ATP is obtained. ATP is an energy compound that is also used to fuel their action. The myosin head hydrolyzes ATP to ADP and an organic phosphate. The myosin is now at high energy configuration. The actin and myosin create a cross bridge. The ADP and inorganic phosphate molecules are released, and the myosin goes back to its state of low energy configuration. This causes the actin to be moved towards the center of the sarcomere. The binding of a new ATP molecule releases the myosin head from the actin. The final stage is relaxation. Relaxation occurs when stimulation of the nerve stops and ATP is no longer available. Calcium is then pumped back into the sarcoplasmic reticulum, breaking the link between actin and myosin. Actin and myosin return to their unbound state, causing the muscle to relax. During rigor mortis, a lack of ATP disables the myosin heads from detaching from the actin. During this, the calcium ions leak from the sarcoplasmic reticulum, which is unable to recall ions into the muscle fiber. The ions perform their task as if the body were alive, disengaging the tropomyosin and the troponin from their myosin active sites. The muscle contracts when the myosin shifts, but the lack of ATP prevents it from detaching, and the muscle remains contracted, resulting in rigor mortis.
Thank you so much, Dr. Elise Nelson, for teaching us about the muscle contraction.
Oh, no problem. I hope you understand it more now.
Thank you. Tune in tomorrow morning at 9 a.m. Bye, guys.
There's only one way, you know.